Ladies and gentlemen, please welcome to the stage Hortonworks Japan Marketing Director, Mr. Kimihiko Kitase.
皆さんおはようございます。Hadooop サミット2日目ですけれども、皆さん昨日はお楽しみいただけたでしょうか。で今日はですね、昨日はですね、MC が英語だったと思うんですけども、今日は日本語で MC をしていきたいと思います。改めましてホートンワークスの木瀬と言います。よろしくお願いします。はい、最初にですね、本日は朝早くからですね、こちらの基調講演に参加いただきまして誠にありがとうございます。あとですね、昨日も気づいたんですけども、日本からだけじゃなくて、海外からの参加者もたくさんいらっしゃいます。私もちょっとあそこのコミュニティブースでショーケースでですね会った方で言うと、例えば韓国の方だとか中国の方だとかインドの方だとかタイ、オーストラリア、あとロシアの方なんかともお会いしましたけれども、そういったお客さんがいらっしゃってます。この場を借りて遠くからですね東京にHadooopサミット東京に参加いただきましてありがとうございます。こちらのHadooopサミットですけれども、参加者だけじゃなくてスピーカーですね、スピーカーもですねいろいろな国の方がいらっしゃいます。セッション数はですね約50ぐらい、48とかって言ってましたっけね、50ぐらいあってですね、そのうちのおそらく半分ぐらいが英語のセッションになっています。英語といってもですね、日本人の方が頑張って話すものもありますし、海外の方が話すようなところもあって、非常にですね、国際色豊かなイベントになっているかなと、うまく特色なんかをうまく出せたかなと思っております。さらにですね、そのセッションの半分はですね、実はだいたい25から30ぐらいですかねはコミュニティからの応募によって成り立っているというかなっています。で実際にですねコミュニティから応募があったのは実はですね200以上応募がありました。で、8月中旬ぐらいまでちょっと応募してたんですけども、200以上の中から約30弱ぐらいのセッションが選定されて、こういった形セッションの方になっているというところで、コミュニティの方にもですねこの場を借りてお礼を申し上げたいと思います。ありがとうございます。それでですね、次ですけども、クリックアウトとスポンサーですね、こちらのサミットですけども、こういったリクルートテクノロジーズ、共催いただいたリクルートテクノロジーズ様をはじめとしたこういった多くのスポンサーの方に支えられてこちらのサミットが成り立っていますので、こちらもこの場をお借りしてですねスポンサーの皆様にもお礼を申し上げたいと思います。で最初にですね2日目のキーノートメインセッションに移る前に昨日ですね1日目のリキャップということで少し振り返ってみたいと思います。昨日の基調講演はショーン・コネリーの方からどちらかというとデータ活用の概要だとか、あとビジネス系の話がありました。でさらにですねパネルセッションではコカ・コーライーストジャパン様、あとですねダイムラー三菱ふそうトラックバスですね様からデータの活用についての話をいただいたり、リクルートテクノロジーズ様からお話をいただいたりしたような形になっています。なおですねコカ・コーライーストジャパン様とダイムラー三菱ふそうトラックバスの詳しいセッションをですね今日ブレイクアウトセッションで予定されてますので、もし詳しく聞きたい方はそちらに足を運んでいただければと思います。さてですね、2日目の話に入る前に、最初にネットワークの環境ですね、Wi-Fi の ID というのは Hadooop サミット東京と、パスワードこちらになりますけれども、こちら接続できますので、こちらを使って、ハッシュタグ、ツイッターなんかアカウントを持っていらっしゃる方はですね、HS16 東京でですね、こちらの会場に来られない方のためにも情報の共有とか、この場の雰囲気なんかを共有いただければと思います。それではですね、お待たせしました、2日目の基調講演の最初のスピーカーをご紹介したいと思います。皆様盛大な拍手でお迎えください。ホートンワークスのチーフアーキテクトであり、コーファウンダーのサンジェイ・ラディアです。Please come up to the stage.
Well, good morning, everyone. My name is Sanjay Radia. Thank you all for coming to the second day of the Hadoop Summit. I hope you had a good day yesterday, and I hope you have a fantastic day today with a lot of interesting breakout sessions after this. So I've actually been involved in Hadoop from the early days. I was part of the original team that started Hadoop at Yahoo, and then I went on to co-found Hortonworks. Today we're going to talk about some of the key milestones from the early days of Hadoop, and then we're going to focus a little bit on the work that we're doing with respect to the cloud, and we're going to have a very interesting demo on our offering on the cloud that we have been doing a tech preview for the last few months. That's going to be going GA in middle of October. So the Hadoop journey began in 2006 when at that time we focused really on kind of two things, parallel computing using the map-reduce paradigm and petabytes of scale of data. And that was our key focus. And at that time, a key decision was for Yahoo to contribute Hadoop to the open source community. And that was very critical because it led to creation of a vibrant set of technologies like HBase and Uzi and Zookeeper, and later on to things like Spark. So it really was a very, very significant event to do that. Let's fast forward to 2011, and that was a very key transition point because that's when Yarn was introduced. And the goal and the significance of Yarn was the fact that it moved Hadoop from a batch-only map-reduce paradigm to something that could become a true data platform capable of running batch, interactive, and real-time applications. Okay? Yarn was actually quickly adopted to do that. A number of ISV platforms came on it. And new technologies like Spark and Flink also run first class. In fact, right now, Yarn is one of the best platforms for running Spark. The other part, the significant thing I want to talk about a little bit is to talk about SQL on Hadoop, because SQL is a very, very important component on top of Hadoop. And Apache Hive has participated in the same move from batch to interactive, from ETL only to a full-fledged enterprise-ready EDW platform. Okay, a significant point of that transition was TES, and TES was that occurred in 2013 is when really Hive moved from using MapReduce as its implementation to doing a first-class native implementation using TES, and this gave it the first performance speed boost. Okay, later on in 2015, recently we added ACID and improved the ingestion of the continuous ingestion of data, so you don't have to be in a batch format and to be able to do updates on your data. We also enhanced that with governance using the Apache Ranger technology, which integrated with Atlas, and so that give you enhancement of really security. The latest thing that we have introduced this year is LLAP. And it provides a very, very significant architectural change to Hive and to the set of technologies similar to Hive. Okay? So LLAP really has three significant parts to it. One is it provides a daemon for executing threads. So instead of process creation, we do thread creation. We get much improved instruction cache, and also we get much improved JIT. And therefore, this gives a significant performance improvement. The second thing is that it also caches columnar data, only the data that is in use, and it can cache from anywhere, from an HCFS compatible file system, if it's a real HDFS, or even the very slow cloud storage. Okay? In addition, LLAP also does columnar access control and gives fine-grained access control, not just to the Hive engine, which was possible before, but to Spark or Pig or even old-fashioned MapReduce if you desire. Okay, so LLAP actually has, as you can see in the graph behind me, that it has given over 25x performance. I didn't say not 25%, but 25x performance improvements over Hive on 1.6. Okay, so this has been really a very significant improvement, and we see this technology playing a very significant role in the coming years. So after 10 years, Hadoop ecosystem is available everywhere. It is available in your data center. It's available in appliances. It's available in private and public clouds. Okay, so that gives you a lot of choice in where you want to run Hadoop, and you decide what is the right pricing model and the ecosystem for your transformational use cases. So I'm going to focus a little bit on the cloud. Okay, and so why do people want to use Hadoop on the cloud? The cloud makes your business very, very nimble. Okay, you can create a Hadoop cluster in minutes on the cloud. Okay, similarly, the cloud actually saves you money and time. You only pay for what you use. Okay, so you pay for what you use and when you use it. The cloud is also very flexible. So you can select an ephemeral cluster, analyze your data, and shut it down and stop the meter. Also, it offers a lot of elasticity, which means you can scale up and down on demand on your compute nodes, and also your storage is much more infinitely scalable. So we've been working with Microsoft over the last few years, and we offer a premier Hadoop first-class experience on the Azure cloud. We call this HD Insight. Okay, and we made a number of enhancements with our partnership with Microsoft for Hadoop to run really well. And we are continuing this work. And today's focus, I'm going to talk in my keynote about why and some of the improvements we are making that you're going to see that are coming out with Hadoop on AWS. And also, these improvements will also be fed back into our HD Insight experience. Okay, so the first and important thing to kind of realize is that shared data on the cloud is the cloud storage. Your data lake is on the cloud storage. It is not on HDFS. Also, memory and local storage play a very different role than that of caching on the cloud. Okay? An important distinction on the cloud is on-demand ephemeral clusters. And this is going to change things in a number of fundamental ways, as I will cover in my talk. Shared data, shared metadata, governance, and security continue to remain to be important in the cloud as on-premise. However, they need to be adjusted to work better in the cloud. And finally, I'll touch on elastic resource management. And here we need to shift our thinking from cluster-centric resource management to workload-centric resource management to meet SLAs. Okay, so let's focus a little bit on the shared data and storage. So in the cloud, the shared data, like as I mentioned, is the cloud storage node HDFS of a specific Hadoop cluster. In fact, this is very different from the traditional on-premise because each cluster had its own data lake. In this case, the data lake is the cloud storage. Now, it's very important that this data lake is available not just to all Hadoop applications running on whichever Hadoop cluster that you've created, but it must also be available to cloud-native applications and also to third-party applications. Okay? Otherwise, it would not be a true data lake. Okay? However, cloud storage has really two key limitations. One is the fact that it only offers eventual consistency, which becomes a problem that needs to be addressed. And the second thing is API is really not what most traditional applications expect or what Hadoop applications expect. Okay, so this is going to be an area of ongoing investments, and we made some improvements over here. The second thing is that cloud storage is really designed for two things, low cost and scale. So performance is not its strong point, okay? And it's segregated from compute. And therefore, what happens is you're going to get actually slower performance. And therefore, memory and local storage is going to play a different role than that of caching, okay, to enhance this performance. So let's talk a little bit about caching now. So really, there are two kinds of things that we need to cache. We need to cache tabular data, so kind of data that SQL is accessing, and non-tabular data. So in the case of tabular data, LLAP, that we've introduced this year, comes to the rescue. It lets you cache data across jobs, across engines such as Hive and Spark. Okay? Now, LLAP is very interesting in the sense that it doesn't just blindly cache all the data. It caches only the columns and the portions of the data that is being accessed. Okay? So it's very efficient in its memory usage, which is very important. Also, and the data is stored in an internal serialized form, so it's very efficient in the compute cycles that are taken in order to reuse it as part of the cache. Okay? Today, LLAP only provides read caching, and work is being done to enhance it to provide a write-through cache. Okay? For non-tabular data, HDFS can be used to cache this data. Okay? And therefore, HDFS plays a very different role in the cloud for storing intermediate results, which you don't want to go back to the cloud storage, and also for caching your data. okay? And so it acts as a finely tuned layer between your apps and the slower cloud storage. Now, always-on, multi-tenant, long-running clusters are important for a lot of mission-critical use cases. However, being able to enable an ephemeral cluster that is tuned for a specific workload and created and turned down when that workload is finished is actually really game-changing. Okay, so the agile nature of the cloud lets you do that, something that is not easy or possible to do on-premise. Okay, so for somebody who's interested in modeling or analyzing a particular data set, what they really want is they want to interact with a pre-tuned environment that is pre-tuned for that particular application. So they don't want to worry about the complexities of how do you tune and configure Hadoop or the Hive layer or the Spark layer. Okay, so whether it is data science, whether it is data warehouse or ETL or other kind of workloads, you really want a pre-configured, pre-tuned workload environment. Okay. And we need to be able to manage this workload environment in an ephemeral fashion. So the net here is that we need to focus on delivering a user experience that focuses on business agility, not on cluster management, not on infinite configurability. So let's talk a little bit about the shared data and metadata. So shared data requires that we take now a shared approach to the metadata and security and governance. This was very natural and simple in the on-premise world. In the cloud world, each ephemeral cluster cannot have its own copy of a private metadata. So what you really need to do is have a shared metadata that needs to be stored centrally on the cloud database and needs to be accessible to all the clusters. Okay? So it needs to be able to work where multiple clusters are accessing and updating the metadata. Okay? And the metadata we're talking about is not the classic, just simply the Hive metadata. It includes things like lineage and tracking the provenance of where the data is coming from. It needs to deal with pipelines and your processes. And also, as data is ingested and moves into the system, the metadata needs to be created and adjusted automatically. Okay? So governance and security also continue to remain important in the cloud, and its metadata also needs to be centrally stored and accessed, and therefore projects such as Ranger and Atlas, okay, which provide that functionality on the on-premise, they need to be adjusted somewhat to work more first class in this slightly different cloud environment. Okay, and that's the kind of work that we have been doing recently. Finally, let me up-level a little bit to the resource management. So the cloud is really not about the cluster, but it's about workloads, and it's where resources are elastic. So the YARN scheduler needs to manage resources of the workload in the context of the workload and meeting their SLAs. Previously, remember, YARN used to focus on cluster management, and so that needs to change. So whenever resource is needed, the YARN scheduler needs to get resources that match the needs of that particular workload rather than optimize the resources for the cluster. Okay, so for example, adding compute may not be the best way to meet your SLA because bandwidth or memory may actually be a bottleneck, and therefore spinning up LLAP memory may be a better way your SLA. Okay. Now cloud offers another dimension, and that of cost and budgets. Okay. So there are different costs tied to CPU, memory, data bandwidth, and all of these are elastic resources, and also the cloud offers you to get reserved resources and also to get spot pricing, which are very different prices. So all these pricing trade-offs need to be factored in, and so the scheduler needs to now think about this, which was really not a common thing inside an OS or inside an on-premise Hadoop cluster. Okay, so this new dimension is very important if you want to reap all the benefits of low-cost cloud computing. So to summarize, really, the better you understand your workload, the better you're going to be able to meet your SLAs, and and be able to do it with a much lower cost than you would have been otherwise. So in this context, we're going to give you a demo on AWS HTTP that has been enhanced for AWS. Okay, on the slide you will see a URL that is actually where you can go and download this new technology that we've been enhancing. Okay, and it has been on tech preview, several tech preview releases since June, and this October, in the middle of October, we are basically going to be releasing. In the middle of November, we are going to be releasing GA for that, and in December there's going to be another GA release with some additional features. So we're going to show you a demo for that. I'd like to welcome my colleague Hemant. Hemant has actually been in the Hadoop project from the very early days. In fact, it's going to be a number of parts. In fact, he was the author for the capacity scheduler that is very widely used. Thank you very much, Hemant, for coming on.
Thank you, Sanjay.
And he's going to give you a demo for this.
Hello. Thank you, everyone, for sitting in for this demo. I'm going to give a demo of the Hortonworks data cloud that Sanjay spoke about. And first, let me introduce the demo scenario, so to set context. So this demo scenario is one where the customer is running advertising campaigns and offering promotions for their products on different channels like desktops and mobiles and so on. And what they would like to do is to measure the effectiveness of these promotions. In order to do that, let's say they have collected data from different sources into the cloud storage, and they would next like to run a set of workloads to perform the analysis that they are interested in. And what we will see is how the Hortonworks Data Cloud product enables them to run these different workloads. Okay? So let's switch over to the demo. Right. So what you see here is essentially that the data is stored in the cloud storage of S3. Right? So what you see is the S3 service view of the AWS console, and you see this bucket here which contains all of the data. There are different data sets being collected, one folder for each. So there is information about the campaigns they are running, clickstream generated by user activity, sales information, users information, and so on. So this ties with what Sanjay said, where in the cloud, object stores like S3 are the data lake. And not things like HDFS. So the first workload that we would like to run on this is a regular ETL workload in a batch mode using something like Hive, right? And for that, we need a compute cluster that can access this data in the cloud. So let's switch over to the Hortonworks Data Cloud console. So this console allows users to launch clusters and manage them from a central point of view. And all the active clusters will show up here on this console here. And you can see that there are two different clusters which are already active, and also a link to create new clusters. We'll come to the create cluster in a bit. Let's first look at the clusters that are already running. So I'm going to go into the first cluster. And you can see that there are details about the cluster specified here, like the instance types, the number of instances, and so on. Importantly, there is this annotation here which kind of says what is the type of cluster this is meant for, right? So when we create a cluster, like Sanjay referred to, we are going to create a cluster for a specific type of workload. So in this case, we want to do ETL, so we launch an ETL cluster, right? And when we launch an ETL cluster, what happens is that we prepackage and configure and keep ready the set of components from the HTTP which are useful for running that kind of workload. So in this case, for instance, we come up with Hive and Spark, which are components that are typically used in ETL, right? Now, you see there are several shortcuts and quick links here which allow you to navigate to the user interfaces of the HTTP components. I'm interested in the Ambari Hive view from where I can show some of the scripts that we run. So I have that open already, so let me just go there. So this is the Ambari Hive view, right? And you can see there are two sets of scripts here. The first script is something that creates the input tables. And the input tables are going to map one-on-one with the folders that we saw on S3. So it's very straightforward. So you have a table that maps campaign information, clickstream information, and so on. So exactly mapping to the folders that you saw in S3. The second set of queries are the actual ETL queries, which look at the input tables and perform some standard aggregations in order to kind of lead to the analysis that we are interested in. So for instance, in this case, you can see that we are running some sessionization queries that kind of group the clickstream activity into user sessions. And in the process of doing that, we're also trying to derive some new dimensions from the data. So for example, we're trying to say, has the user switched activity from the mobile to the desktop in this process of interacting with the customer website, right? So a couple of points to talk about these scripts. The first thing that I want to show is the location that is specified in the Hive table definitions. And if you see that this location happens to be an S3 URL, right? So these are the input tables, so the read will happen from S3. And if I go to the ETL queries, you can see that the location of those tables also happens to be an S3 URL. So the write is also going to S3. So this is a case where Hive compute is directly interacting with S3 to read and write data, right? This is one area where Hortonworks, working with the wider Hadoop community, has done a lot of work in the recent few months to make this interaction a lot more smoother. There are improvements in areas of performance, in areas of security, in areas of consistency that are ongoing in order to make this better. The second thing that I wanted to talk about was about the metadata for these Hive tables. So to show that, let me switch back to the Hortonworks Data Cloud console. And under this link called Shared Services, you can see that we can register Hive metastores. These are the instances where the Hive metadata information is stored, right? And we see that there is already an instance created. And from the name, you can guess that this is actually an AWS RDS instance. So in this case, we're using RDS to store the Hive metadata. A couple of points to call out here. So the first thing is, with data in S3 and metadata stored in RDS, we are using durable storage for these two aspects, right? But the compute clusters, like the Hive ETL cluster that we just saw, they can be launched on demand, and they can be shut down whenever you don't need them, like Sanjay mentioned. But as long as they're pointing to these durable services, they will get the same view of the data whenever they come up. The second point to show here is look at the fact that more than one cluster is associated to this service. So we also saw the ETL cluster just now, and I'm going to show another cluster. And this means that data that is created by one cluster, like the ETL cluster, can be shared by another cluster, like the analytics cluster. And so everyone gets a consistent view of the data that's in the data lake. OK? So now, let's say we have generated the required, through the ETL scripts, the required derived tables. And now we would like to go on to the next workload, which is an analytics workload. So in the analytics workload, what we expect is a business analyst would come in and fire some fairly interactive queries on the data that's been derived, right? And would possibly want to visualize the information of the results of those queries so that they can understand what is happening with the data. So in order to do that, we go to the analytics cluster. And you can see that this is a different type of workload. This is not a batch workload, right? This is an interactive workload. And because it's an interactive workload, we prepackage it and install and configure a different set of components. So in this case, it happens to be Hive LLAP and Apache Zeppelin. Hive LLAP provides for interactive queries, and Apache Zeppelin is the component that allows you to visualize this data using different visual widgets. So again, you have these quick links which are convenient to take you to the specific UIs. I'm just going to go to the Zeppelin UI, which I have open here already. And you can see that Zeppelin allows you to organize these results in the form of something called notebooks, right? So this is a notebook which has been created for measuring the effectiveness of the mobile campaigns. And you can see different histograms and other visualizations that kind of talk about the analysis that is done. So if I expand one of these query editors, you can see that these queries are running using Hive as the backend, which is backed by LLAP. And it's accessing exactly the same data sets, either the input tables or the ETL tables that were created in order to get these graphs. So let's just quickly look at some of these graphs. So like you can see that the campaign ID is I'm sorry about that. The campaign ID is stored here, and we are displaying that against the desktop sales and the mobile sales, right? And it looks like the desktop sales are dominating the mobile sales pretty much for every campaign. So if this company were running mobile promotions, then a question could be, is that being effective, right? Now, in order to answer that question, we can drill down into the data and use some of the fields or dimensions that we have created in the ETL scripts. Like, for instance, remember that we were capturing information about whether the user was switching from desktop to mobile and so on, and vice versa and so on. And using that, we can see that even though there were desktop sales, some portion of this was actually coming because of the mobile promotions. And that's significant in number of campaigns, right? And you can also further drill down and get specific numbers. For instance, it looks like whenever there are mobile promotions that are run, about 30% of them seem to be happening because of mobile conversions, right? So this is a conclusion that could be drawn because we had the analytics cluster that was allowing us to test different hypotheses in a very interactive fashion and visualize them and understand what is happening with the data. Now, let's go back to the Cloud Console, and I would like to see how to create a cluster. So let me select this link here. And you see this form, which is, as you can see, it's fairly small for the amount of heavy lifting that's going behind the scenes. Some important fields that I'll call out, the cluster type, for example. This is where we want to show that you choose the type of workload that you want to run on the cluster. So we have support for running data science workloads, ETL workloads, or analytics workloads like we just saw. The other interesting thing to call out here is this particular ETL workload is coming with Apache Spark 2.0. At Hortonworks, we feel that the cloud is giving us a unique opportunity to push the latest versions of these technical components in front of the customers much sooner than we could before, right? And through that, we can actually have customers test this with realistic cluster scale, right? You can have a cluster which is realistic according to your expectation. It can actually query data that you already own, and thereby get some real feedback about whether these components are working for you or not. We are very excited about this particular feature. You can see that you can select the instance types that you want, the size of your cluster, and then there are certain security options that you can set up. I want to focus on some of these security options. So particularly this thing called an instance role. Now, if you saw the Hive queries that are there here, you would have seen that there are no S3 access credentials that we have specified. There are no secret key, password, and so on, right? And these also do not exist on the cluster configuration. Instead, the way we bring security to this environment is we integrate natively with the cloud provider security mechanism. In the case of AWS, that happens to be IAM, right? And when you're launching a cluster, you can specify either, you can let the product create an IAM role for you, or you can choose one of the existing roles that you have defined. And against this role, you can set up different access policies. These access policies will specify which buckets you would access and what is the level of access. So for example, for the analytics cluster, you could say these are the buckets to access, whatever we saw, and we can say just give read access. Do not give any read-write access. And by virtue of specifying this role and these policies, what happens behind the scenes is that everything that's working on that cluster, whether it's Hive or Spark, is bound by those access policies. And so you'd get a very consistent security model, right? And then you can see this is the Hive metastore. This is where we specify which metastore to use to get the shared view of the data. And once you've filled all this, you create the cluster, at which point we get we provision the instances from EC2, install the HTTP stack, configure it according to the components that are set up, and just give you those shortcut links where you can access it, right? So for all that work that happens, this is all the form that you need to fill. Now, let me go to the last part of this, which is to show how we can take advantage of the scalability offered by and the elasticity offered by the cloud. So let's say your ETL workload requires more compute capacity on one of the days. Maybe there's a surge in data, some festival season, and so on. So when you go into this cluster details page, you have this action. You have this link called cluster actions, and then you have this option to resize the cluster. And you can increase the number of nodes that you want to attach to the cluster. And once you've done them, you can bring it down as well. And once you've done that, just select the resize cluster option. And literally at the click of a button, you have more capacity on your cluster. This is for cases where the admin already knows when to provision extra capacity. In the product, we are also working on a way to do this in an automated fashion, depending upon different rules and so on. So that was like an overview of the different features available with the Hortonworks Data Cloud product. We saw how to create different cluster types according to your workload. We saw how we can increase the capacity of them on demand. We saw how we can share metadata and data from S3 and RDS. And so I hope that gave you a good idea of the capabilities we have today with the platform. So with that, I conclude my demo and hand it over back to Sanjay. Thank you.
OK. Thanks, Hemant. Thank you, Hemant, for the demo. I hope you guys enjoyed the demo. Just got a couple of slides to conclude the presentation. So we've talked about so far about the Hadoop journey from its early days and focusing more on recent and ongoing work on the cloud. So our focus is really on providing you continuous insights, on all your data, from its origin to data at rest while it is in motion. As we do this, we really emphasize a very key enterprise requirement, that of management, security, and governance of your data, regardless of where your data sits in that journey and transition in your data lake. You may choose to deploy this particular, your business applications and your Hadoop clusters on the cloud on-premise, or you may actually have a hybrid model. In yesterday's keynote, Sean talked about a connected car and showed you a hybrid environment where you had manufacturing data and data live from car. And so those are all the kind of things that we want to enable. As always, all our work is always in open source. We lead with innovation in many areas in open source, like the work in LLAP recently, like some of the cloud work. But we also adopt innovative technologies and integrate those technologies from the open source ecosystem. So Hortonworks really helps turn bleeding edge ideas like the connected car into practical business opportunities. We blur the boundaries between where your data is sitting in and whether your cluster is on-premise or on the cloud, and where your data is and how your data moves around. We call this the data plane. So think of the data plane really as a high-level abstraction of the data lake. That a data lake originally, that when we introduced that idea and concept, merely focused on the data storage. The data plane really talks about your data in all dimensions, about data at rest, data in motion, and as it's moving in. And it allows you to ingest new data streams, leverage data in real time, and deal with your data regardless of where it is. At the same time as it does this, it continues to focus on making sure that your metadata is kept consistent and there's governance and security continue to apply across all this data. So it really delivers a really profound business value. So with that, I'd like to kind of conclude. Again, I'd like to remind you that that's the URL where you can download our cloud offering called HCS that runs on Amazon. And we have a number of tech previews, and we'll be having a GA very, very soon in the next 15 days or so. Thank you very much.
Thank you very much, Sanjay and Hemant. It's great presentation and demonstration. And 日本語ですね。日本語で、これからいきたいと思いますけれども、次はですね、お客様をお迎えして、のパネルセッションになります。今からですね、お客様をお呼びしますので、皆様盛大な拍手でお迎えください。1人目はですね、ヤフー株式会社データ&サイエンスソリューション統括本部データプラットフォーム本部本部長日比野哲也様です。皆様拍手でお迎えください。続きまして2人目はですね、株式会社リクシル情報システム本部インフォメーションエクセレンス部部長勝負正樹様になります。この二方と、パネルセッションを始めていきたいと思います。よろしくお願いします。
よろしくお願いします。
よろしくお願いします。
じゃあ初めにですね、皆様のそれぞれの自己紹介と、会社の紹介とか、あと Hadooop をどういうふうに利用されているかというところを、それぞれお聞かせていただければと思うんですけれども、じゃあ初めに日比野さんの方からよろしくお願いできますか。
はい、ヤフーの日比野と申します。よろしくお願いします。私はですね、今データプラットフォームというところの、一番の責任者をしております。ヤフーっていうのは日本のインターネットの会社で、ニュースとか検索とか e コマースとかさまざまなアプリであるとかウェブサービスっていうのを提供している会社になりますと。事業としては広告とか会員サービスみたいなのが大きいです。でHadooop の利用もでしたっけ。
はい、そうです。
Hadooop の、どうやって使ってるかなんですけども、一番大きいのはそのレポーティングとか BI みたいなところなんですけども、他にもレコメンデーションのモデルを作るためのデータ処理であるとか、広告のためのセグメントのデータを作るとか、そういったところに Hadooop を使っています。
そうですか。ありがとうございます。じゃあ続きまして、リクシル様の方から同じように自己紹介と簡単な紹介と Hadooop の利用のところを簡単に、
はじめましてリクシルの勝負と申します。リクシルっていう会社はですね、ちょっとあまり実は知られてない会社でですね、ぜひちょっと宣伝したいなっていうところでここに来てるところもあるんですけども、もともとですねトステム、イナックス、新日経、サンウェーブ、東洋エクセリアという5社がちょうど5年前なんですけども、2011年の4月にですね、統合してリクシルという会社になっています。ですからもともとのトステムとかイナックスとかサンウェーブとかっていうふうなですね、そういったブランドの方が非常に強くて、残念ながらリクシルというのはあまり知られてない。一つだけ今日お願いしたいことがありましてですね、トイレ作ってるんですよ、リクシルっていうのは。でトイレというのは一つ大きな会社がありまして、うち2番目なんですけども、ウォシュレットっていうのはですね、あっちの会社の製品でですね、ですからよく温水便座のことをウォシュレットというのはですね、今日限りやめていただければと思ってます。うちではシャワートイレと呼んでますので、ぜひシャワートイレということでこれからよろしくお願いします。はい、
はい、ありがとうございます。それではですね、ちょっと本題というかですね、技術セッションというところでですね、少しもうアーキテクチャとかどういったそのデータプラットフォームのアーキテクチャをお二方構築しているのかっていうところを少し突っ込んで話を聞いていきたいと思います。ではですね、ヤフー様非常に大規模なクラスター構築されていると思いますけれども、そのアーキテクチャ周りのところをご説明いただければと思います。
はい、ヤフーのデータプラットフォームっていうのは大きく2つ、ヤフージャパンのプラットフォームですけど2つのタイプがありまして、1つはそのデータストアを、データストアのプラットフォームというのがありますと。具体的にはそのリレーショナルデータベースであるとか、キーバリューストアであるとか、オブジェクトストレージであるとか、そういうものですね。本当に箱として機能する、データを置いては引くみたいな、そういうようなものがあります。これもかなりの規模がありまして、データベースだと800データベースあったりとか、キーバリューストアだと2000ノード、オブジェクトストレージも1500ノードくらいとか、かなりの規模のものがありますと。でそれとは別にHadooopを中心としたその、私たちはログを扱っているのでアクセスログですね、ログのプロセッシングのプラットフォームがありますと。 それは一番大きいのがHadooopで、3800ノードぐらいのHadooop がありますと、一番大きいものですね。他にもちっちゃいものとかもあるんですけど5つぐらいのクラスターがあって動いてますと。でそのHadooopにデータを集めるシステムっていうのもありまして、その集めるシステムだけでだいたい1000ノードぐらいですかね。1日多い日で300億イベントぐらいのデータを集めてHadooopにロードしているという形です。で集めるシステムの途中で分岐してリアルタイムのシステムに流したりとかいうことをしてます。
ありがとうございます。そのプラットフォーム上で、もう少しどういったデータだとか、アプリケーションサービスとかっていうものが動いているのかっていうところを少し、お聞かせいただけますか。
そうですね。まずデータストアのプラットフォームの方ですと、データベースはですね、その Yahoo! Japan のサービスのほとんどのデータが置かれています。例えばニュースの記事ですとか、あとはお客さんが書き込んだ情報ですね。Yahoo! 知恵袋っていう Q&A のサービスがあるんですけど、そこで書き込まれた書き込みであるとか、そういうものはそのデータベースのプラットフォームに入ってますと。あとキーバリューストアのところだと、例えばお客さんのユーザーさんの情報ですね、属性の情報みたいなものは貯めていたりしますと。でアクセスログの方は、本当に検索したであるとかページを見たであるとか、最近だとどういうリンクを表示して何がクリックされたかであるとか、あとは画面をスクロールしたであるとか、そういった情報を取って分析をしているという感じですね。
なるほど、ありがとうございます。ではですね、リクシルさんの方ですけども、ヤフーさんと比べて、エンタープライズでの利用というところでですね、最初に、どういった構成というかなっているところをちょっと教えてほしいのと、あとそのエンタープライズで利用するときに気をつけないといけないポイントなんかありましたら、ちょっと教えていただければと思います。
じゃあちょっとスライドの、
はい、
先ほど申した通りですね、リクシルというのは5社が統合した会社でしてですね、残念ながらまだ今のは旧5社のシステムをなんとかつなぎながらスパゲッティみたいな格好になってですね動かしている、そういった状況なんですね。それを今基幹システムの刷新ということで全部変えちゃおうというんでですね、今SAP 社のHANAをベースにしてERP は全部 SAP の方に乗せ替えるっていうふうな一大プロジェクトが今動いています。でその中でここにちょっと書いてある通りですね、情報分析基盤というですね、これは今回私たちが今作ろうとしている、ERP のデータなんかを全部この絵の書いてる通りデータ連携でですね持ってきて、それをですね統合してダッシュボードであったり、KPI のレポートであったり、あるいはデータサイエンティストが使うようなアナリシス、そういったものをですね全部できる基盤を作ろうということで、今回選んだのがですね、もともとがERP がHANAですので、BI のHANAをベースにしてますけども、これだといろいろデメリットが結構多いんでですね、今回Hadooop と組み合わせることで、HANA とHadooopを組み合わせることで、それぞれの利点を生かしてですね、大容量のデータを効率的にかつ安くですね効率できるということでですね、HANA とHadooopの組み合わせをで後ろの書いてる絵のような形をですね今実は構築しようとしてますと。で、一つは今回基幹システム含めて全部刷新するんでですね、ちょっと今までのアーキテクチャだとやっぱり古いんで、どうせ作り変えるならば一番新しいテクノロジーで作っちゃおうということでですね、このような形を今考えて、中には花ぼらも今回使うつもりでしております。はい、
今週リリース、
花ぼらまだですね、どんなものか分かんないんですけどとりあえず入れてみようかって感じでですね始めてます。
そうですか。
はい、
エンタープライズでの利用をする際にどういったところがポイントとなったりしますか。
ですね、先ほどから話してるですね、このそのデータをですね今やっぱりエンドユーザーコンピューティングっていうんですかね、みんなやっぱりいろんなところからいろんな形で引っ張ってきて、それぞれのその分野の人間がですね自分好きなようにダウンロードしてアクセスなりエクセルで加工しているっていうふうなやっぱりその現状から キーワードはですねワントゥルーナンバーなんですよ。ですから全て一つのところに置いといて、そこからですね、データをですね、その時点の正しいデータを引っ張ってきて、誰がどうやってもデータは同じデータを使うというですね、そのコンセプトのもとに今回この基盤を作っています。はい、
はい、ありがとうございます。じゃあちょっと時間もだいぶなくなってきているんですけれども、最後にですね、ヤフー様の方から、日比野様の方から今後の展開というか、今後どうしていきたいとか、そういったところがありましたらですね、ちょっと聞かせていただければと思うんですけども。
大きく2つありまして、1つはその、インフラのアーキテクチャというかです。データストアとログのプラットフォームがありますということだったんですけども、それをさらに進めてですね、先ほどの基調講演でもあって方向性が一緒なんですけども、やっぱりデータを永続化するストレージのプラットフォームと、その上でワークロードを動かすような計算のプラットフォームと、コンピューティングのプラットフォームという形に分けていきたいなと思いますと。そうすることで多分インフラもその尖った構成とかが取れるようになって、効率的にも良くなってくるのかなと思ってますと。でそれが一つ、でもう一つが、データをつなぐところを簡単にしたいというふうに思ってますと。2つのアプローチがあると思ってて、入り口と出口ですね。データを入れるときにいろんなデータをつなぐというのを簡単にするっていうのと、出口の方はそのクエリを投げてデータを引くときに、複数のデータソースを引きやすくするという話があって、前者の方はそのデータフローみたいなものが出てきてるんで、そういったところ、後者の方はいろんなデータストアをつなぐようなクエリエンジンみたいなものをこれから実現していきたいなという感じに思ってます。
そうですか、ありがとうございます。同じ質問になるんですけども、リクシル様の方での今後の展開というか、
そうですね、今後の展開というか今作ってる最中なんでですね、一応ですね、目標は2018年の1月にカットオーバーするというふうなところで、今ですね一生懸命テストしているというふうな、新しいものをいろいろ取り入れてやっています。でその中でですね、何でもかんでもとりあえず Hadoop に入れちゃえというふうな発想はあるんですよ。ですからIoT のデータであったり、それから当然うちメーカーですので自分のところのファクトリーのIoT のデータもありますし、外のデータもありますし、家の中のセンサーのデータなんかもあると、そんなものも全部放り込んでいきますし、当然あれですね、Google アナリティクスのビッグクエリなんかとああいったものに放り込んだデータなんかも全部ですね入れてきてですね、データサイエンティストがそこの今回の作った環境データ情報分析基盤の中にデータが全部あるから、それを要は好きなようにね、みんながデータサイエンティストあるいはそのエンドユーザーがですねどんどん加工してですね、要はそのリクシルのビッグデータ、この辺をですね支えていきたいなというふうに考えています。
なるほど。データレイクを構築するということですね。ちなみにクラウドでの展開とかっていうのは考えていらっしゃるんですか。
ですね、今のところはプライベートクラウド、オープンスタックの下で動かそうかなというふうなところで今やっています。
そうですか。オープンスタックといえばヤフーさんもユーザーですよね。
やってますし、先ほど言ったやつだとデータベースとか、マイシケルみたいなものはもうオープンスタックの上でポチポチ立ち上がるような感じにしてますと。で Hadoop もやはりエラスティックな立ち上げっていうのをやりたいなと思ってで先ほどのデモとかかなりメモとか持って見させていただいてました。
そうですね。なんかちょうどオープンスタックサミットの方もバルセロナでやってるというところでちょっと振ってみましたけども、いろいろ他にも聞きたいところはあるんですけれども、質問なんかもいろいろ用意してたんですけども、ちょっと時間がですね来てしまいましてですね、パネルセッションに関してはこれで終わりたいと思います。皆様今一度ですね日比野さんと勝負さんに盛大な拍手をお願いします。ありがとうございます。ありがとうございます。 はい、基調講演はですね、これで、終了しますけれども、最後にですね、少しだけ、ちょっとご紹介させていただければと思います。Hadooop サミットのですね、次の開催都市について、紹介させていただきます。次はですね、ミュンヘンになります。でここにですね、Hadooop サミットの横にデータワークサミットとかって書いてますけれども、データワークサミットという名前で開催することが、決定しております。皆さんですね、もし、コール・フォー・アブストラクターなんかもやってますので、登壇したいとスピーチしたいという方はですね、応募していただければと思います。でこの、Hadooop サミットですけども、近年ですね非常にその規模っていうのが拡大、してまして、Hadooop のエコシステムはですねもちろんですけども、IoT だとか、クラウドだとか、あと DevOps とかですね、ストリーミングですね、そういったところ、あとデータサイエンス、さっきの勝負さんの話にもありましたけども、データサイエンスとか、そういった関連のコンテンツが増えてきて、Hadooop にとどまらず、次回からもう少し、規模を拡大してですね、開催するということで、データワークサミットというふうな名前で開催することになりましたので、ぜひですね皆さん、さっきも言いましたけれども、ぜひコール・フォー・アブストラクトなんか応募していただければと思います。あとですね、最初にも言いましたけれども、こういったサミット会場にですね来られてない方のために、ツイッターのハッシュタグですね HS16 東京もしくはFacebook なんかでですね情報とか雰囲気みたいなものをですね共有いただければと思います。であまりですね日本で知られてないんですけれども、community.hortonworks.com っていうです、フォーラムが技術フォーラムがあるんですけども、これ非常にですね有用な情報なんかがここに載せられたりしてますのでですね、こちらのフォーラムもぜひですね技術的な QA なんかで利用されてみてはどうかと思っています。でこちらのサミット基調講演でこれで基調講演についてはこれで終わりますけれども、この後ですねこの後は11時10分から11時50分まではブレイクアウトセッション3回であります。でその後ブレイクアウト T ですねブレイクアウト T っていうんですかね、少しおやつタイムが入って、でもう一回セッションがあるんですね。もう一回セッションがあってからお昼ご飯ですね。1時50分から少し遅いですけども1時50分から3時までランチと、でその後セッションが続きましてブレイクがあってさらにセッションと6時半ぐらいまでセッションが続いてますので、ぜひですね実は最後のセッション結構面白くてですね、私もいろんなセッション面白いところがあるんでどれが面白いってここで言えないんですけども、最後のセッション非常に面白いものがありますので、ぜひ最後まで聞いていただければと思います。一番最後にあまり日本だと耳慣れないかもしれないですけども、バーズ・オブ・フェザーって言ってボフっていうふうに言ったりしますけれども、コミッターそういった PMC のメンバーとかと、そのオープンソースのアパッチのプロジェクトについていろいろディスカッションしたりするような場もありますので、こちらもぜひですねそういった海外から来ているコミッターなんかとコミュニケーションするいい機会ですので参加いただければと思います。日本で日本人のですねサポーターというかそういったものもつきますので、参加いただければと思います。それではですね皆様残り1日ですけれども、Hadooop サミット、お楽しみいただければと思います。基調講演どうもありがとうございました。